In order to control draft pressure, we first need to be able to accurately measure it. This is done by using a differential pressure transducer. It has two ports, high and a low, and high is tubed to a probe inserted into the vent to sense variable pressure, and the low port stays open to the room where the pressure generally doesn't change. Inside this device is a diaphragm, and when it experiences mechanical pressure, the deflection generates an electric voltage proportional to the difference in pressure between the high and low port. Let's open this up a little. You pop the housing off the mounting bracket like this, and you can look at the specs a little bit. You can see the range here is between negative 1-inch water column of pressure and positive 1-inch water column. The power required is 24 volts, and the output signal is between 0 and 10 volts. What this means is that a draft of 1-inch water column is equal to 0 volts, positive 1-inch water column equals 10 volts, and 0 inches of water column, in other words, neutral pressure, equals 5 volts because it's halfway. And so there's an exact voltage output for a given pressure for everything in between. 3 wires needed. You need power, 24 volts is your output, and then common. And the voltage output will go to a controller, and the controller will use that signal to ramp up or ramp down a fan depending on the pressure, or it can also be used to modulate a damper between open and closed. I'll show you how this is wired and what this looks like installed. Mount the transducer on a non-heated, flat, non-vibrating surface. Once it's wired up, you can apply the housing over the transducer. Connect the 1/4-inch tubing from the high port to the vent probe. And that completes the installation.